everyone, my name is Tim Astris, and I'm here today to show you how to build a model in Python and using Google Colab. Build an AI model. We're going to use cancer.csv data set that I got from another tutorial on the internet. I watched that tutorial. I came up with a different way to make my AI model, and I'm also adding an interface to solve the problem to be able to predict and interact with the model. That's one thing that the other video didn't show that I watched was, how do you interact with the model once you build it? And that's the question I've been looking for a long time. So I found the answer and I wanted to share it with everyone. All right, the first thing you're going to do is open Google Colab. Then you're going to want to attach the cancer.csv file. You just click this right here to upload a copy of it. I'll make sure to have it in the description. Next, you'll want to run this line of code. This is going to install all your libraries and also import the modules of the libraries you'll need to run this Google Colab. So we'll do that right now. You'll notice here the libraries I'm installing: TensorFlow, Pandas, scikit-learn, and Gradio. TensorFlow is AI framework, Pandas is for your data, scikit-learn is your machine learning, and Gradio is the interface. Next, we're going to load the data set. That's the cancer.csv, data equals pd.read_csv, cancer.csv. Then we're going to have it display some information about the data set, the data.head, data.info, and data.describe. There's some other functions you can use in Pandas to view your data without having to go into Excel and open your sheet. You can do it right here in Google Colab. After that, we're going to prepare the data for training and testing, and it's going to split the data into two different sets: X-train, Y-train, X-test, Y-test. And the most important thing when you're looking at this right here, you have your X-axis. X-axis is everything except your target column. Notice we're using data.drop, which is going to drop that column off and grab every other column in that CSV file. And then on the next one, we're just going to, on the Y-axis, we're just going to grab the target column, which is the diagnosis 1 = M, 0 = B. Then we're going to split the training into two sets, or split it into a training and a testing set. And we're going to use 0.2, which is 20% for the sample size. Then we're going to standardize our model. Do that. Next, we're going to build the neural network. Hit play here. And what this is doing is, this is 3 different layers. This has got 64 neurons, and 1 neuron. I'm using the ReLU function on the first 2 layers, and the sigmoid function on the last layer for binary classification. Then I'm going to compile the model. Next, we're going to train the model. What this is going to do is iterate through the data and go through the neural network and find the patterns and increase the accuracy. You'll see as it goes through there, it's going to iterate 100 times. That's what the epoch stands for. Okay, it looks like that's finished up. Next, we're going to evaluate our model. Okay, so our model is 98.246. That's our test accuracy. That's pretty high. I'm really pleased with that. So it's going to give us some real good results on the prediction. Then we're going to save the model. And this is just kind of an extra step, but I'd like to see the model and how many parameters and just kind of the layers of the neural network, which these are 3 layers. You can see 64 neurons, 64 and 1. These are the number of parameters per layer. And you know, those big large language models, they're up in the billions. We're only operating with 6,200 approximately parameters in this model, AI model. Next, we're going to load the interface. I'm using Gradio on the interface, which is really kind of an out-of-the-box solution that works really well with Google Colab. You'll see here in just a minute. But this is going to take the inputs. I have data validation on the inputs, and then it's going to check against the model and give the prediction if the tumor is malignant or benign. So let me run that. Pulls up our interface here. And Gradio can run in a browser also. If you click here, gives you the interface right there into a web browser instead of into Google Colab. I'm going to run through and put some values in here. I'll be right back. All right, now that I got those added in, I'm going to hit submit. Oh, it's going to give me an error. Values greater than. Try that one more time. And the prediction came out as malignant. So you can see it's working. It uses data validation too to make sure that you're inputting the right data. If you don't put in the right value or within the correct range, it will give you an error, as it should. You know, bad data is just a really bad thing if you're not using accurate data. That's all I got for right now. Please leave your comments and any feedback. The way I see this is this gives people a 98% answer on if they have cancer or not based on the measurements of their tumor. Could save people from a biopsy. It could also get their treatment earlier. You know, you're not waiting on the biopsy and lab results. Just thought it could be a useful tool in the healthcare industry. Let me know what you guys think.